Hello, Computer Programming 12 students. This is Mr. Rowell with your first YouTube lesson tutorial. At some point, I should make a cool intro type thing. I haven't got around to it yet, so you get my beautiful Word doc, Computer Programming 12 UML diagrams. In today's overview, we're going to be talking a bit about this thing called Unified Modeling Language. It's kind of a standardized way that we visually represent the complexity of our design in object-oriented programming. UML diagrams are used in many different forms and structures. There's many different strategies. I'm going to teach you the one that I'd like you to use in our course. And we're going to be using a site called Lucidchart. So in order for you to get set up and going, you may even want to pause this, lucidchart.com, heading here and creating your own profile. And once you're in there, you would want to create a new UML diagram for computer programming. And once you're inside of it, you're going to see a bunch of options that you have on the side here. I'm just going to take you through a brief example of what some of these things mean, as well as an overview of a basic program outline that I've developed to show you some of the logic that I might use in an RPG like you've been working on. The primary section we're looking at here is actually this one box under UML Class Design. I'm just going to zoom in on my diagram here, and anytime you create one of these boxes, it's going to summarize the information that's in these boxes for you as a reminder. I'm going to go over it now though. And the top of the box is going to be the name of your class. Maybe in your exercise you're working on, maybe the name of this would be like Student Tracker, like an example problem we did recently, or maybe it would be like the world for your game, or whatever you want it to be. It's the name that you're giving your class that's descriptive and concise. In the top box here is where you're listing all of the private attributes of this particular class. And we have a few things to look at as we list these attributes. On the left, we either have a plus or a minus. The plus simply means public, and the minus means private. Generally speaking, we want to have private attributes as often as possible so that we can maintain what we call encapsulation, meaning keeping the fingers of other classes away from data it shouldn't be able to touch. And we kind of want to have attributes set private and then have getters and setters to be able to access this information when we want to be able to. So you'll notice that we have the name of the attribute, colon, its type. I want to swap the spots on there, oops. We'll see some examples of this kind of as we go along over here. You can have as many attributes as you want per class, or maybe even none depending on what you're working with. And finally, down at the bottom here, we have our methods. Again, public and private methods. Public to be able to access methods once you instantiate an object of this class, to be able to access whatever you might be accessing, some kind of a command, maybe a getter, maybe a setter, so on and so forth. Or maybe you have private methods that just operate within the class itself with some kind of functionality. Up to you to decide how you want to implement these types of things. And we write them with the name of our method, the parameters that it might be receiving, and then if it returns, or if it's blank, if it doesn't return, that would be a void method here. So those are the boxes that define our class information. We also have a couple other pieces of information that we want to be aware of. The types of class relationship. There's two different types. Composition, meaning that in this relationship, the class that's listed below cannot exist without the class that's attached to above. So if this class were to be removed from your program, then the attached class would also be removed. We also have aggregation, where this information is allowed to stick around. It can exist independently of what it's feeding or what it's attached to. And we'll see an example of this in the program that I show. We're also going to look at inheritance briefly, which is pretty simple with a set of arrows, but we'll get there in a moment. All right, first things first. The first class for my RPG game, I've called it World, and it's a pretty simple class. It simply has a private attribute, a string, that is the name of the world, and it's going to be a private variable. I've also listed here, now I could go into a lot more detail for this, but for now I just simply summarize this as saying this world's going to have a lot of custom methods for basic gameplay flow and logic. Maybe I have some methods that create some dialogue, maybe some methods that allow for user input, maybe some methods that pop up messages to the user, to the player. All the types of things that set kind of like my initial gameplay flow and logic could be created as custom methods in many different forms and formats and styles, depending on how your game would like to function. In this UML diagram, I've simply just overviewed the main classes that I need for the basic functionality to work. So let's take a look down below here. Let's not look too far ahead. You'll notice, let's just zoom in here. I've created another class called Player. This class must or can only exist in a world class. If the world disappears, so does the player. Its existence is dependent on the existence of the world. And this number 1 that I've put along this line tells me that I'm only going to have one player in my world. No more, no less. I'm limiting my world to a single player object. Within player, I have some private attributes. The name of the player, their health, attack, magic, and wits, some different statistics for them. There could be a much bigger list of statistics if you want more complexity in your game, but my player just has this basic list of attributes. And for these attributes, the player is going to have various attribute getters and attribute setters here to be able to access these private, see the minus sign, pieces of information that we have in our player class. I didn't list them all here, but we all know how to create our getters and setters at this point. Now this player is going to be able to have its attributes set by another class called job. And note that this job class is able to exist independently of player. It can exist out there without a player being created. Its function in my program is to feed information to the player to help define its statistics based off of the player's choice of different classes. My choice here to include the job as connected to the player could be done in many other ways. You could have the job connected to the world class itself, feeding information that would be sent to the player, or you could have it as a different type of data structure altogether, just storing information that you access in a different manner. But for simplicity's sake, I decided to create a unique class for it. And within this, I've decided to include an array of strings. That's the list of all the different names of jobs that might exist in my game. Maybe I just want to have a few options, or maybe you want to have 10 different job possible class options. I would list all the names for those in one section of data, and then in another set, maybe it's one long array list. In this case, I just set an array of integers. I might list the different statistics in the order that I might want to access them. Maybe the first number inside would be the HP, and then the second one would be attack, and the third would be magic, and then the fourth would be wits. Or maybe I would want to organize my data in some other way. For now, I'm not too concerned about that particular logical decision, but I do want to note that I'm storing the information about each of the jobs whose names are above in an array that I might be able to access to assign values to my player. And again, I have attribute getters and setters to be able to access and work with this information, potentially sending the information to my player to help determine its statistics if I choose a job at some point or when I choose that job. So there's an interaction between these two classes that's represented by this arrow. Now let's take a look over here again. In my world, I have a couple different options for objects that can be created. We already covered player. There must be one existing in my world. Or I have enemy. Now, something that I want to actually edit here really quick is that enemy, I don't necessarily have to have enemies in my world. I can have no enemies at a given point, and there can still be gameplay going on. For example, maybe my player is just choosing their job, maybe doing some dialogue and getting set up in the world. There doesn't need to be any enemies in existence just yet. But maybe an enemy will show up, and maybe many enemies will show up. This dot dot and then asterisk means that there can be any number of enemies that I want to create. Hundreds, thousands of them if I want, based off of the rules of this class. It's up for the logic of my game world to decide how many enemies there are. And again, enemies must exist within the game world. This filled in diamond, sort of diamondy shape here, tells us that it must exist within the game world. Each enemy has its own set of private attributes: a name, private string, health, private integer, attack and defense. Again, you could add many more if you wanted to. And then it has its own list of getters and setters for these attributes to be able to manipulate that information. Maybe different enemies that you construct will have different names, different attributes and parameters that define its behavior, define how hard it is, maybe easy, medium, and hard enemies, however you want to craft your game world. And then we see that there's another class I've crafted for battle. This is where the action of our battle arena is going to be occurring. And we'll note that it's receiving or interacting with both the enemy and the player class. Now, in this particular UML documentation strategy, I don't have a great way yet. Maybe there's something that I can decide upon for the near future about how we can represent that it requires at least one of each of our enemy and player for this battle to be created. There is no battle unless there's at least one enemy and one player, right? Logically speaking. However, in the battle, I'm only going to be sending one player, but I could potentially send many enemies to fight that player at the same time. We can also extend our thinking a tiny bit and consider maybe a game that's a bit more complex, where maybe we have a multiplayer scenario, or maybe even a larger party where there could maybe be many characters, each with their own unique job. Maybe this could increase to being one or more players or characters in a larger party, and then you could have one or more being sent. But in my basic functionality, I'll keep it simple, only one player character, and thus there's only one that's able to attend this battle. In the battle, I've just made sure to be really clear that inside of it, there needs to be a player and an enemy, potentially many of them, that their data is stored locally. So that means that this battle is going to have to receive all the information from the enemies that are participating and the players that are participating, so that it knows what to do with them and their statistics. And in here, there's a bunch of methods, an options menu that gives the player choice about what they want to do for their actions, what happens during a player's turn, what happens during an enemy's turn, when a player chooses to attack, what the results are, when an enemy chooses to attack, what the results are. Perhaps there's many more methods that we might want to include in here for different scenarios, potentially using items, seeking information, who knows what other functionality you want to add into your battle system. This would be the place to note the methods for that, the way you want to name them, if there's any return values, and so on and so forth. Lots of room for development of complexity inside of this class for sure. All right, let's keep on moving. Attached to my player class, I have another class called inventory. Note with the filled in diamond that it is, once again, let's look up here, composition. It cannot exist without. The inventory is attached to the player it's created for. Can't exist without it. Note that I've given an option for an inventory to also exist for an enemy. Perhaps there's enemies that are simple, they just attack, they don't need an inventory. Or perhaps an enemy could use an inventory if it's a more complex character. You have to program some AI for that as well. But I'm leaving this option open to include an inventory for an enemy, but we definitely want to have an inventory for each, well, for the one player that's in our world. And if there was more than one inventory, one for each of the players that exists. In our inventory, I have a few different gameplay mechanics that I've included. Potions, scrolls, and bombs. In here, I just store the number of them that I have. And inside of here, I actually haven't developed all the logic in here. I've kind of left it blank, but maybe I would consider a method that's like use scroll. And this using scroll perhaps would improve the statistics of my character for a short amount of time, or perhaps cast a spell of some sort, or who knows what other functionality you might want it to do. But I would have a method to use it. And perhaps I would have another one, throw bomb. And this would probably do damage, maybe poison, or cause some status ailment, depending on how complex you want to go. Here, I need to do some more development of exactly what I want my inventory to be able to do. Again, your own choices within your own game for what the functionality could be. What I really want to finish this video off in more detail is this section on potions, where we're going to see something called inheritance at play, with a parent class and some child classes that extend from it, just to recap this more complex idea in object-oriented programming. You'll notice that in these three different potions, I don't have any information attached to them. I potentially could, but for now I wanted to keep it simple. I've defined all the rules for how potions work inside of my potion class. The number of pots, potions that there are, the value, meaning how much it will affect a certain statistic, and its name. I've also had getters and setters for these different attributes. Adding potions, removing potions, setting and getting the values. in case the potion's amount they heal or the amount of damage they do, however it might work, want to be adjusted at some point in the gameplay. And all the rules are defined right here locally in potions. And now I've created 3 types of potions that we're going to say do something called, in our Java, we would say, extends. This means that this is a child class of the parent class potions, and it inherits all of the methods inside of this. So we can consider that in our mana potion class, all of these methods are actually there, as well as in health and stat potion, because they're all children class of our potion parent class. So each of these 3 different types of potions have access to all this information here, which means that we don't have to keep on retyping out the same code, having it in multiple different spots, making our lives more complex. We can simply just know that potions have a set logic to them, and then we can run that logic in each of the scenarios that extends it. I could also create some custom methods or logic that's unique to each potion. Maybe in stat potion here, I say a method that says select stat. I want it to be able to determine which statistic is actually going to affect. So it already has an ability to set the value, how much it's going to improve that stat, but maybe I don't know for how long. And in fact, maybe I need a method for effect length, how long the strength increase will last for. Mana potions and health potions are just a one-time use, bam, that statistic increases, but stat potions might work a little bit differently, so I might want a custom method for this. Within each of these, I'm going to want to have some information about their names. So I might have now these attributes aren't inherited from the potion class. So I might have a string for their name. I might want to have a value for their effect. And other information here as well. The number of pots that I have for here. But one of the great things that I can do now is that whatever type of potion it is that I create, whether it's a health stat, mana, or other potion that I may create in my game world, I know that they're all following the same basic set of getters and setter rules, just with their own unique take on it. This one will affect the health, this will affect the mana, this will affect the stats, maybe it has its own unique methods, but it's extending the functionality of this core one, allowing us to save some time and be more organized in our coding structure. So here we have kind of a brief outline of how I might set up all the different classes that I work with in my game. I just want to show you really briefly here in my NetBeans, in my game package for my battle arena, I have a different Java file created for each class. And you notice that the classes are named based off of the same way that I organize things in my UML diagram. Each one's an independent file responsible for its own set of information. Here I have some logic for what goes on during a battle. My world itself allows the player to be created. It's creating a player class or a player object by instantiating the class. It's creating an enemy, and then it's sending the player and the enemy to a battle to participate in the battle. And there's lots of different functionality going on in here. My enemy has its own getters and setters for its information. I have a bunch of different jobs defined, a constructor that determines which job is selected, and then getters and setters for all that access. And then my potions, a whole bunch of information about the potion class that then each of my other potions is going to extend. And each of these things is going to be able to borrow the information from the potion class that's above it. In a future video, we're going to talk a bit more about how we could actually use something called superclasses to be able to extend this extension functionality with a little bit more advanced object-oriented programming, and talk a bit more about some of the logic that I've used in the way that I've constructed things to give you some ideas for how to make your own RPG battle arena a little bit more sophisticated and organized and working in an object-oriented paradigm. Hopefully that's helpful. Make sure that you begin work on creating your own UML diagram for the current way that you've designed your own Battle Arena RPG. Thanks for watching.